increasing angle of attack and decreasing angle of attack. Some people unfortunately never understand the relationship between a stall and angle of attack aerodynamically. I'm going to make it simple for you. As I just showed you, this is a side view of an airplane traveling from your point of view from right to left. You are looking at the cross section of the wing here in black. Let's define two terms, relative wind and chord line. Very simple. Our chord line, it's an imaginary line from the front of our wing out the back. It's just an imaginary line going from the leading edge or the front end and out the trailing edge of the wing. Our relative wind is simply going to be the opposite of our flight path. So if we are traveling in this direction, the relative wind is in this direction. What's the angle of attack? It is the degree between our chord line and the relative wind, adjusted with pitch, like so. So, as we see here, the angle of attack is simply the angle in between that chord line and the relative wind. Now, what's a critical angle of attack and what's the relationship with a stall? Well, as we know, when we increase this angle of attack or pull back and add back pressure, we may increase lift with the increased angle of attack if proper airspeed is there. Well, what happens when we approach and the critical angle of attack is we actually stall the aircraft. And what's happening here is the smooth airflow over the top of the wing ends up separating from the top of the wing, creating microturbulent disruption on the top of the wing, and this airflow gets separated and we no longer produce the sufficient lift, and so a stall is that rapid loss of lift in the aircraft until we recover. We must understand that once we exceed that critical angle of attack, the airplane is in a stalled position and must recover, and the only way is to break that critical angle of attack and decrease our angle of attack by pitching down.